We have a winner. That's right, the 100th video free periodic table poster contest has been won by hodgeslindsey. So hodgeslindsey was the first to be subscribed to my channel, have the video in her favorites, and correctly answer the question on the original video. So if you're wondering what the answer to the question is, what the correct answer to the question is, well, let's consider the original. Let's consider the question here. So the question was, if I have 12.002 grams of sodium chloride NaCl, how many molecules is this? And the correct answer to this question is 0. So if you're wondering why the correct answer to this question is 0 molecules, you have to think about pretty much all the parts of the question. And the most important part of the question is the compound itself, NaCl. So the question is, what kind of compound is this? NaCl is an ionic compound, not a molecular compound. So you have to remember that ionic compounds don't form molecules. They form lattices. So let's just go back to just a simple comparison of ionic and molecular compounds for a minute. So let's compare the ionic compound sodium chloride to the molecular compound hydrogen chloride, HCl. Notice that in HCl we have just nonmetals, and in NaCl we have a metal and a nonmetal. So the NaCl, that is an ionic compound, and the HCl is a molecular compound. So if we were to look at these things at the molecular level and see, or the atomic level, and see what's going on, we'd see something that looks like this. I'll do NaCl first. So imagine that the red atoms are, I don't know, the sodium atoms, and the blue atoms are the chloride ions. So let's see, NaCl. I'll color code it for you. So if we look at the NaCl structure, we see that each red atom, so each sodium ion, is surrounded by these chloride ions. And if we were to continue drawing this out, we would see that each chloride ion is also surrounded by sodium ions. Okay? So, in other words, let's look at just this central sodium ion here. This sodium ion right here, this is equally attracted to all 4 of these chloride ions. And this structure actually repeats in 3 dimensions. So if you imagine, you can actually imagine another chloride ion right on top of this sodium ion. Okay, do you see it? It's kind of where my pen is, just above the sodium ion. So this structure actually goes on in 3 dimensions. And notice that, you know, the sodium ion is no less attracted to the chloride ion, this chloride ion, than to this chloride ion. So these ionic bonds here that hold the sodium ions and chloride ions together, they're not directional at all. In contrast, if we look at the HCl, if we were to look at a sample of HCl, we'd see all these individual HCl molecules. Okay? You'd see a bunch of these little individual HCl molecules. Notice this doesn't form a lattice. This forms these little discrete entities. Okay? So in other words, the bond between this hydrogen and this chlorine, this bond here, these 2 atoms are a lot more attracted to each other than, say, these 2 atoms. These are discrete molecules here. So a lot of you who submitted answers to this question. By the way, thank you everybody who submitted answers. Thank you for your participation. A lot of you, just sort of jump right into the calculations, but really all you have to know, I mean, this particular question was a lot simpler than it appeared. So hopefully, the point of this whole contest was to just, maybe clear up this discrepancy for a lot of, because I get the feeling that a lot of people, when they see, the formula NaCl, they sort of get the idea that there's one Na and one Cl and they form these discrete entities, but that is not the case. Instead, you have these 3D repeating lattices that just keep going on and on forever throughout the entire solid. So there you go. Once again, congratulations to the winner of the contest. Your poster is in the mail. So, all right. Take it easy, everybody.